give it another few minutes for others to join. Everybody see all that all right?
Yeah.
Okay. Most people did pretty well on the homework because this is probably the most complex differentiation you're going to have to do, the kind of chain rule applied to trigonometric functions, because a lot of the time, as you will have seen if you did the work, there's 3 different functions going on. So question 1 was pretty okay, I think. Any questions on that? All right. Question 2 is getting a little bit more complex, so I'm just going to do parts 3 and 5. So y is tan to the power of 4x. Now, if you're getting confused about doing it the quick way, you can write out the chain rule fully. The whole point of the chain rule is to try not to have to write it all out. So to identify all the different functions that are going on. So with this one, basically, if u is tan x, then y is u to the power of 4. Okay, because when we write the power for trigonometric, we put it in front of the tan, the whole thing is the power of 4. It just avoids using the brackets. That's the same as tan x, the power of 4. So this is u, and then we're saying u to the power of 4. So the 2 functions that are going on, if we differentiate tan, we get sec squared. And if we differentiate u to the 4, we get 4u cubed, which is 4 times tan u all cubed, or tan cubed x. Okay, so then you're fine, and then you just multiply those. So you've got 4 by tan cubed x by sec squared. And the order of these doesn't really matter, except I have the number first. Now, if you want to do it the quick way without doing all of that, you come along here, you say, okay, I have to deal with the power of 4, so I bring the 4 down and I subtract a power to make it 3, so that's 4 tan cubed. Then I have to differentiate the tan, which is sec squared. The x, or whatever is the input to your trigonometric function, whether it's x or 5x or 10x squared minus 6, that's an angle. Because remember, sine and cos and tan, it's a sine of an angle, whether it's in degrees or radians. And the angle isn't going to change. The input to the tan and the sec and the sine and the cos and whatever are not going to change. So if we look at another one from question 2, you've got y is equal to tan cubed 4x plus 3. So 4x plus 3 is our angle. Okay. So when we're differentiating or using the chain rule here, first of all, you could have u is equal to 4x plus 3. And then you'd have v is equal to tan cubed u. And then you could have another one, y is equal to v cubed. So you've really got 3 things going on here. And you've got u prime is 4, v prime is 3 tan squared. Sorry, u is equal to tan u. Sorry, v is equal to tan u. So that's sec squared u. And y is 3v squared. So this would become sec squared u is 4x plus 3. And this is 3v squared, which is tan squared of 4x plus 3. So you have 3 different functions going on there, u, v, and y. And that's why I said it starts to get a bit complicated if you're trying to use the chain rule there. So you look at the algebra part first. d dx of 4x plus 3 is 4. Look at the tan, that's sec squared, and its angle is 4x plus 3. And then you look at the power of 3, you bring down the 3. and everything else stays the same. This goes down by 1, and the input or the angle stays the same. And then you can multiply it out to 4 3s is 12, x squared of that angle times tan squared of the same angle. Okay, so to avoid having to go through all of this, you kind of need to practice identifying how many functions there are and differentiating each one on its own. Any questions on that? You okay? All right, question 3. I think a few people got a little bit confused because instead of x, we're using theta. Theta is just a variable that we often use for angles. It's just another letter. So you just treat it the same as x. And if you notice, it says dy d theta, not dy dx, because our variable now, y depends on theta, it doesn't depend on x. And for those, they were fairly straightforward. I'll just pick number 2. So y is tan squared theta plus tan 2 theta. So we have dy d theta. So with this, we have two things going on. We have the tan and we have the squared. So if you do the squared first, you bring down the 2, keep your function the same and just reduce the power by 1. So that's the squared differentiated. Differentiate the tan is sec squared. And that's that whole thing. If you want to do it separately, u is equal to tan theta. B is equal to u squared. U prime is sec squared. B prime is 2u, which is 2 tan theta. And then you just multiply that by that. This one, differentiate the algebra, which gives you 2. Differentiate the tan gives you sec squared. And the angle is still 2 theta. So the angle or the input to sine, cos, and tan never changes. Is that okay? And then I'll just do question 4. We just put part 1 straightforward. I'll just do part 3 of question 4. So that was y is equal to x plus 3 times sine x. So this is a product rule. So you have to, with the product rule, I wouldn't try and do it quickly. I'd write it out. U is equal to x plus 3, and that's multiplied by v, which is sine x. So u prime or du dx is 1, v prime is cos x. And the product rule says uv prime plus vu prime. So it's that by that, which is x plus 3, and you need to put that in brackets because you're multiplying the whole thing by cos x. And then plus this by this, 1 times sine x. All right, so with these, you're putting together product, quotient, and chain rule. The product and the quotient, I would write out you're using these. The chain rule is to kind of aim to get past having to write them all out and be able to identify all the different functions and differentiate each one separately, and then you just multiply. Okay, I may give you an IXL exercise to practice those, but I want to just go back to example 3 and where we're actually evaluating these, because it's going to be a little bit different now because we've got angles rather than just plain x. So if we go to example 3 on the previous page, we've got f of x is equal to 1 plus sine x over cos x. Show that f prime of x is that, and hence evaluate. This is, what rule do we need to use here? It's one thing divided by another, so that's, what rule is that? Quotient. U is the top, 1 plus sine x. V is the bottom, cos x. U prime is going to be cos x. V prime is going to be minus sine x. Okay. And then we've got VU prime, so that's cos squared x, because it's cos by cos. And when we're squaring trigs, we put the square after the function rather than put the whole thing in brackets squared, okay? It's just to make it quicker to write. Minus this, so I've got minus sine is plus sine x times 1 plus sine x. Okay, that's those two. So does everybody see where the plus is coming from? Minus by minus would give me plus. So all over v squared, so that's cos squared x. I don't write cos bracket squared, I write cos squared x. Now, multiplying out the top, you've got cos squared x plus sine squared x, all over cos squared x. Now, in the tables, on our page in trigonometry, we have what's called trigonometric identity. So if we talked about this before, cos squared plus sine squared is always equal to 1. Does that ring any bells with people? No? Yes? No?
No.
We will come back to that, and I think it's a little bit tricky here because with some of the trigonometric functions, we haven't dealt with how to change them around. But that's basically another version of Pythagoras' theorem. Okay, because if you have your unit circle, remember the unit circle, what's the radius of the unit circle equal to? What's the radius of the unit circle, this distance here, or this, or this? What does unit mean? Come on, guys. Radius of the unit circle is 1. Any point on the unit circle, and it's drawn here for you. Any point on the unit circle is cos A sine A or cos X sine X or whatever you want to call your angle. Okay? So if the X coordinate is cos, so that would be cos. The Y coordinate is sine. And using the theorem of Pythagoras, that squared plus that squared equals that squared. So cos squared plus sine squared is always equal to 1. And if we come back here, we have cos squared plus sine squared, so that's equal to 1 plus the sine x all over cos squared x. So you can check that out in your calculator if you pick a number like cos 30, okay? If you do cos, and the calculator can't do the, let's just do cos 20. And we square that. Plus sine 20. And we square that. Doesn't matter what number I put in there, it's always going to equal 1. Okay? So now the next part of the question is evaluate f prime. So that's f prime of x. They're saying evaluate f prime of pi. Okay? So we're going to be doing this in radians. So it's 1 plus sine pi over cos squared pi. And remember, again, going back to the unit circle, you could put that into the calculator, but it's quicker. Pi is here. Okay, the coordinates at this point are -1, 0. And that's cos pi, and that's sine pi. So you've got 1 plus 0 over -1 squared, which is equal to 1. So you're just subbing in, this is your angle, so it gets put in wherever the x is. So looking at some of these other questions here, yeah, we might have to do the trigonometric identity. Okay, so we're going to look at question 7, 9, 7, 9, 10. 12, 15, and 16. Okay. With these, I'll do 17 as well. Okay, and look at 17, the slope of the curve. What's the slope of the curve? It's dy dx. So you work out dy dx, you sub in pi over 3 and you let it equal to 0, and then you find your value of k. So in all of these questions, you're just getting dy dx, and then you may or may not have to sub something in to work it out, okay? I just want to check out something on IXL as well. That might be good practice for you. But if you can get started on those now. And then from tomorrow, the rest of the week, I'm just going to do a bit of revision with you. Just to get ready for the test, okay? Yeah. Yes, pi. So just take out your calculator and stick in the value. So it'd be, that's going to be, so when you derive the first one, you're going to get 2 cos 2x. So you're going to have 2 cos of 2 pi. And actually, you can avoid the calculator because it's pi, it's very easy. And because it's 2 pi or whatever. Again, with your unit circle, pi is here, 2 pi is here. Remember, cos is just the x coordinate, sine is the y coordinate. So you've got like 1, 0 and minus 1, 0. So it's just going to be multiples of 1. Okay. So cos of pi is minus 1, cos of 2 pi is 1, sine of pi and sine of 2 pi are both 0. So it should be very easy to work out. Okay. You don't really need the calculator for those. Okay. You doing okay there?
Yeah.
I'm just not sharing the screen, but I am still here. Okay. So. Any questions? They working out okay?
Yeah.
Anybody want to check on anything? Yep. Okay. I'm just getting my screen share. Oh no. Sorry, sorry, my book disappeared. Hang on one sec. Excuse me. So question 9. Sorry. And given that f of x is that I'm in third form. So third form just means it's a square root. And so basically you're going to do chain rule here because you've got f of x is sine x plus 1 squared. So u is what's in the brackets, and then so that's u squared, okay? So if you ignore that, you can bring down the 2, and you've got what's in the brackets to the power of 1, okay? And then you differentiate what's in the brackets, which gives you cos x, okay? So that's what f prime of x is. And then you just sub in pi over 6. Now, what I do there is, well, you can use the calculator if you like, or you could use the tables. Remember, pi over 6 is one of our standard angles. So if you go to page 9 or page 13, pi over 6 is here. So I can go in and I can do twice. Sine pi over 6 is 1 over 2. Okay. And cos pi over 6 is root 3 over 2. And then you've got 2 by 3 over 2 by root 3 over 2, which is 3 root 3 over 2. Those twos will cancel. Does that make sense? Okay, so, I mean, you can put that into the calculator, but it's pretty quick to do out of the tables either. And the calculator should be set up to give you your answer in third form as well. So you're just subbing in pi over 6 for wherever there's an x. That make sense?
Yeah.
Any other ones before I let you go? Will I keep doing the video solutions? Are you finding those useful?
Yeah.
Yeah, okay. Right, I'll go do them now, and should have them up later on this morning or early this afternoon, okay? And I will see you tomorrow then. So we'll start. I'll post up a thing just with, there's basically 4 topics on the test. We've got the calculus, so I might do a very quick revision of calculus tomorrow. We have coordinate geometry, we have geometry, and we have probability. Okay, so that's your topics that are coming up, so we could do kind of 1 to 2 a day over the next couple of days, okay?
Yeah.
All right, guys.
Thanks.
Take care.
Thanks.
Okay.